our video. In first video we have discussed from sample A to sample E, and we found that sample A contains aluminum ion, sample B contains zinc ion, sample C contains calcium ions, sample D contains iron 3 ions, and sample E contains copper 2 ions. That was included in our previous video. Now we have 4 more samples: solution F, solution G, solution H, and solution I. You can observe these 4 solutions have different colors. It has light green color or yellowish green color, you can say yellowish green. This is dark green color solution, and this is pink solution, and this is bright green solution. These colors themselves show the presence of certain ions. The light green or the yellowish green color shows the presence of iron 2 ions. Dark green color shows the presence of chromium 3 ions, and the pink color shows the presence of cobalt 2 ions, and this bright green color shows the presence of nickel 2 ions. As these all are colored ions, so you can easily guess that these are the transition metal ions. Almost all the transition metal ions, which are the typical transition metals, they give colored solutions. So again we will do the same work that we have done previously with sample A to E. Now we will add a small quantity of sample F and another test tube that is marked F, and I am adding sodium hydroxide just like before. So you can observe, please observe the change in color. This is called dark green PPT. PPT are scattered, but if you observe, then these are the dirty green PPT. And the same test will be conducted or carried out with ammonium hydroxide. So I have taken a small quantity of sample F and I am adding ammonium hydroxide. Here again the dirty green PPT are formed with ammonium hydroxide. In both the cases, if you do it in excess, PPT remains insoluble. Again, you can do the same with ammonium hydroxide. Even in excess, PPT remains insoluble. So observe the result. Iron 2 ion, it gives dirty green PPT, and PPT remains insoluble in excess as we have observed here, and with ammonium hydroxide in a small quantity it gives dirty green PPT again, and PPT remains insoluble. Now come to the sample G. In sample G, we will perform the same test first with sodium hydroxide. I should take a small quantity. So we are adding sodium hydroxide, and in excess, I think I should do it again because immediately I have added more sodium hydroxide in it. So I am taking the small quantity of this iron, and I am adding the small quantity of sodium hydroxide. You can observe the dark green PPT are formed here. Dark green PPT. But when I am doing it in excess, these PPT will dissolve. See here. Now the solution is again transparent. What does it mean? It means PPT has been dissolved. So what should be the result? The dark green PPT are formed from chromium 3 ion and PPT dissolved in the excess of sodium hydroxide, as we have observed that there is no PPT, solution is again transparent. Now we will repeat the same experiment, same test with ammonium hydroxide. First we will add a small quantity of ammonium hydroxide and you should observe the result. Again, the green PPT form, and in excess green PPT remain insoluble. It means it might be the chromium. So the sample F was iron 2 plus and sample G was containing chromium 3 ion. And it is by mistake that I have kept it open. All the detail must be closed. Okay. Now come to another sample H. So in sample H, you can observe the color is pink. Again, we have taken a small quantity of this pink solution, this sample H, and I am adding a small quantity of sodium hydroxide. Oh, what's the change? Blue precipitates are formed. These are precipitates, particles are there, not solid. Okay? And even in excess, no precipitate are solid. It means they remain insoluble. Definitely, color itself is showing that it is cobalt, and our results are also showing that it is blue PPT with small quantity of sodium hydroxide, and this PPT remain insoluble in its axis. Now, another solution, another test with the same solution. What is this? Sample H, that is blue in color, and now I am doing it with ammonium hydroxide. First, small quantity. Oh, what a beautiful color! Cyan blue color is obtained, and sometimes we obtain the blue coloration. Cyan blue coloration with pink shade. You should observe one more thing. I will perform another test with sodium hydroxide, ammonium hydroxide. I am keeping it here and I am doing the same test with very small quantity of ammonium hydroxide. See here, what is this? Blue PPT is formed, and in excess this blue PPT becomes cyan. Okay, so what is our result? In ammonium hydroxide, blue PPT form and PPT remain insoluble, and color changes to sea green. See here, this is sea green color, and this color is different from this blue color. You can observe, you can compare these two colors. So in a small quantity it is giving blue precipitate, in large quantity the precipitates remain insoluble but color changes from blue to sea green. Now come to sample I. In sample I, again we will perform the same test here. Very light green precipitates are formed, and even in excess PPT remain insoluble. Just like this, light green PPT form and PPT remain insoluble. Sometimes some author write it apple green. I don't know whether the apple is of this color or not, but In some books it is written that these are the apple green precipitates. And again you can observe, now I am testing ammonia solution or ammonium hydroxide. What is this? It is giving dark blue coloration. It is giving dark blue coloration. I want to share one more thing with you. So I need to test tube. First we will wash the test tube with tap water, and we always rinse the tubes or any glassware that we are using for our chemical test with distilled water, because tap water contains some ions which can interfere our result, but distilled water contains no ion. Why I am taking this test tube? Because I want to show you a different result with dilute ammonia solution. I am just making it dilute and taking it, and now you can observe I have taken the solution as much and double quantity of water is added. Now it is a dilute solution, and see the result with dilute solution. With dilute ammonia it is giving the same result as with the sodium hydroxide, and I already written here the light green PPT form. But with concentrated ammonia it is giving the blue color. So it is another observation, but I have not written here because it is above our level. Okay? So that was the last part of our cations. Okay?